Hello everyone. Today we'll have the discussion on one of the important topic which has vast application in maths, physics, and through which we can plot various diagrams. So let's start with the topic which is differentiation. We'll have discussion on its method, meaning, rules, and many more things. I'll be providing two videos of this topic. So first begin with the term meaning of differentiation. As we all know, differentiation is defined for the term y equals to fx, and its meaning is rate of change of y with respect to x. We can see that del y upon del x is defined as rate of change of y with respect to x. We can also write del x upon del y, which is nothing but rate of change of x with respect to y. We know that del y upon del x is the differentiation operator, but del upon del x is called the differentiation operator. And if the changes are infinitely small, then in place of del x upon del y or del y upon del x, we use dy upon dx. And we can represent the term differentiation by a dash, like f dash x or y dash. It can be read by y dash or y prime. Dy by dx can also be understood by the terms like instantaneous rate of change of y with respect to x. Now let's move forward and see the derivative of a constant, and mainly the formula of the term differentiation. There are many formulas in this topic. So let's see what are these. Like the differentiation of a constant is always 0. Like 2, 3, you can take any number. And the second one, like differentiation of x to the power n. The power n comes down and we have to do the power by n minus 1. Like it's called the power rule, n x n minus 1. You all have to learn these formulas. These are very important and these are the basics of differentiation. These will be helpful in class 12th and class 11th as well. Now let's see the differentiation of sine x. It's cos x. Don't mix it with the integration part. It's reverse in the integration. I will be providing the lecture on that. Now just see the cos x is minus sin x. Tan x sec square x. Cos x is what? Minus sin x. And cosec x is minus cot x into cosec x. And sec x is sec x into tan x. We also see that the cot x is minus cosec square x. Now just remember that only tan and cot have the square terms. Let's first finish all our formulas. We'll see the log and e to the power x is Euler's constant. Its value is 2.71. The log is 1 upon x log e to the base e. E to the base e will evaluate into 1. So the answer is 1 upon x. We'll do the same thing with e to the power x. The differentiation of e to the power x is same as e to the power x and log e to the base e, which will evaluate into 1. So the final answer is e to the power x. Note that log x to the base e or Euler's constant will evaluate into ln x, which is natural log. Note that the log with the base 10 is common log and with the base e is natural log. Now just see one important concept behind it. In the green cloud, d sine x square upon dx square. Note that sine x square and x square, both in the numerator and denominator, they need to be same, otherwise it will not be defined. So this will evaluate into cos x square, as we have seen that d sine x upon x is cos x. So x square upon x square will evaluate into cos x square. You all have to learn these rules. Now just move to the basic concept or rule of derivatives through which we'll be able to solve some questions. Now see the rules. We'll be covering 6 important rules. First is constant multiple rule. If we multiply any constant with function and we have to take the derivative of that function, so the constant c will come out of the differentiation operator and will evaluate into c into differentiation of fx. So before moving to second rule, we first have to note that u and v are the function of x. Now just see the second rule, which is sum rule, which can be defined as y equals to u plus minus v. The rule of sum is same for subtraction and summation. So the differentiation of it will be distributed among the individual term of plus and minus. So we have covered for summation and subtraction. Now let's move to the product rule. Y equals to u into v. It's very important. Dy upon dx is u into differentiation of v plus v into differentiation of y. We have to switch to the individual term u and v. Now just move to another slide and see the rest of the rules. Fourth is quotient rule. Is stand for y equals to u upon v. In this, the differentiation of u upon v is we first need to take v square in the denominator, lower term first and the upper term in the numerator, like v into differentiation of u minus u into differentiation of v, in the same way we have done in product rule, but here the difference is of plus and minus. Let's move to the chain rule. We can solve many questions with this rule. You should note this rule. Chain rule is applicable for two different functions of x. We should note that those both the functions should be different from one another. Let's see that dy upon dx will equals to differentiation of first function and the differentiation of second function. For the first function we have written f dash, as we have seen earlier that f dash is the differentiation of f, and the second we have written du upon dx. We have also a direct method to solve by chain rule. We first have to solve the first function, then we have to go to the second function. We'll understand it better with an example. Here in the example, y is given as a function of three different functions. First is log, then sine, then the different x square minus 4x plus 5. Now first in the direct method, we have to solve the first function, then second, then third. In the first, we have seen that the log is converted to 1 upon x. So here will be 1 upon sine and the whole function. The second, we have seen that sine converts to cos, so cos and the same function. And the third, we have to differentiate by using the sum rule. We have seen it here only as 2x minus 4. So we all know that cos upon sine is cot. So the final answer will be cot the third function into 2x minus 4. It is the derivative or differentiation of y. I think you all understood all the 5 rules. The 6th rule will be discussed in the second part of this video. So let's move ahead and practice some of the important questions. So our first question is where to find the differentiative of sine 3x plus 5. First we should let it to be y. Then dy by dx will be the differentiation of sine 3x plus 5. We'll do it by chain rule. we should let the first function to be sine and the second one to be 3x plus 5. As we know that the differentiation of sine is cos, so it will evaluate into cos 3x plus 5, and the differentiation of 3x plus 5 is only 3. So the final answer will be cos 3x plus 5 into 3, or 3 into cos 3x plus 5. We will let it to be y dash. We can also read it as y prime. So it's an easy question. So let's move to the second question. So this question is based on power chain rule that we haven't discussed in this video. So those who know this can solve. But note that it's not tan 2x, it's tan x to the power 2. So we'll discuss this question in our part 2. So our third question is, note this question was asked in JEE Mains Round 12. So the question says that we have to find two numbers x and y such that x plus y is 60 and x into y is maximum. Note that this question is based on maxima and minima, which we haven't covered in this video. We'll be seeing it in the second part. So let's discuss it here. Those who want the explanation, they can switch to the second part and then come here and see the solution of this question. Those who know, they can solve. X plus y is 60, so y is 60 minus x. So x into y can be written as x into 60 minus x, which is 60x minus x square. We should let it to be z. The differentiation of this function will be 60 minus 2x. So x is 30, and we should put it in the x plus y is 60, as y will also be 30. If we have to find the maxima and minima, we have to do the double differentiation, that is nothing but the differentiation of the derivative that we have find it earlier, which is 60 minus 2x. So the double differentiation will be minus 2, which is negative. And for the maxima, if the double differentiation is negative, so it will be maxima, and if positive, it will be minima. So we'll be seeing the concept of maxima and minima in our second part. So let's move ahead and I'll give you some questions to practice. All these questions are very important. You should comment down all your queries. I think you know this question, it was very important. All these questions are very important, so you all have to comment down your answers in proper numbering. So all these are very important. You should solve them. The first, second, third, all these are based on basic knowledge, but the fourth one is very important. It is based on power chain rule, which we will be discussing, but you should try it with another methods. I'll be providing the answers of all these 6 questions after second part. So till then, solve all the question and comment down your answers. So the first question can be solved by using the sum rule and the power rule and many more rules. And the second question, we have to use the tan, differentiation of tan, and differentiation of x square. In the third one, we can do it with power chain, but we should do it with chain rule. The fourth is very important. We have to do it power chain, but you can try with chain rule. The fifth, we all know that e to the power x, or differentiation of e to the power x, is e to the power x. So you should note this question. The sixth one is very easy. So let's end our session here. So if you have any problem, you can comment down your problem with the questions, or if any topic is not clear, you can comment down in the comment box. I will surely be seeing, or our tech team will answer all the queries. So thank you guys.